Hello, everyone. Welcome to another episode of Deep Dive Knowledge Talk. Welcome to our technical talk show. Today we'll delve into vector embeddings and their impact on natural language processing. We'll explore their limitations and discuss alternatives for more accurate information retrieval. What are vector embeddings? And why are they commonly used in natural language processing for tasks like information retrieval?
Vector embeddings are like giving each word a special code that captures its meaning and how it relates to other words. Imagine if you had a giant box of crayons, where each crayon is a word. Some crayons are very similar in color, while others are different. When we need to find a crayon that matches a picture, we have vector embeddings help us identify which crayons are closest in color. In natural language processing, vector embeddings are used to help computers understand text better, especially when looking for information. For example, if someone asked a question about glasses, the computer can use vector embeddings to recognize whether the person is asking about drinking glasses or eyeglasses by finding the related words stored in its code. However, while vector embeddings can help find information quickly, they don't always understand the full meaning of a question, and sometimes they can lead to incorrect answers. That's why instead of relying solely on them, they should be used to refine the search after using other methods, like looking for synonyms. This way, the system can bring the most relevant answers to the front, just like picking the best crayons for drawing a picture.
How does the reliance on vector embeddings for determining percentage of sameness in RAG lead to inaccuracies in the answers provided, especially in various contexts, such as people, places, and instructions?
Relying on vector embeddings to determine percentage of sameness can lead to inaccuracies, because it can mistakenly treat different words or concepts as being more similar than they really are. Imagine you have a box of fruits. If you are trying to find apples, but the box also includes oranges and bananas, using just a simple measurement of how similar they look might lead you to think that an orange is almost as good as an apple. For example, when looking for information about a king, vector embeddings might rate queen as being very similar, even though they are distinct and refer to different roles. In this scenario, the computer would think that information about queens is relevant when searching for kings, which is not helpful. This issue is not limited to just people. It affects various contexts like time and places as well. If someone asks about the 1900s, passages about the 1700s should be completely irrelevant. But vector embeddings might still rank them as somewhat similar, because they are both historical periods. In short, vector embeddings can confuse things that are distinctly different. Instead of accurately identifying what is truly relevant, they can lead a search to include unrelated information, which makes the answers less accurate and reliable.
What limitations have studies identified regarding advanced RAG techniques and larger language models in addressing the inaccuracies caused by vector embeddings and information retrieval?
Studies have identified significant limitations in advanced retrieval-augmented generation, RAG, techniques, and larger language models when it comes to addressing the inaccuracies caused by vector embeddings. One key finding is that even when combining various advanced RAG methods, the resulting accuracy is still low, averaging around 0.446. In real-world applications, this level of accuracy is impractical for chatbots that need to provide reliable answers quickly. For instance, one combination of techniques took over 11 seconds to process a single query, which is too slow for effective use in a conversation. Additionally, there is no evidence showing that even the most advanced RAG techniques, when paired with vector embeddings, can create a reliable chatbot capable of handling numerous documents effectively. The added delay from these techniques further complicates their practical application. Another important point is that using larger language models does not necessarily improve accuracy. Studies have shown that even well-tuned models that are supposed to refine search results only achieve modest scores, indicating that the fundamental inaccuracies originating from vector embeddings remain unresolved. In summary, the limitations of advanced RAG techniques lie in their low accuracy, slow response times, and their inability to overcome the inherent flaws of vector embeddings. making them unsuitable for reliable information retrieval in real-world scenarios.
What alternatives or methods could be considered to improve the accuracy of information retrieval systems, particularly in the context of addressing the shortcomings of vector embeddings in RAG?
To improve the accuracy of information retrieval systems and address the shortcomings of vector embeddings in retrieval-augmented generation, RAG, several alternatives and methods can be considered. 1. Synonym-based search. Instead of solely relying on vector embeddings, using synonym-based search can help identify relevant information more accurately. By finding words with similar meanings, it ensures that related concepts are included in the search results. 2. Hybrid search techniques. Combining keyword-based methods like BM25 with vector embeddings can enhance retrieval accuracy. This way, the system can leverage the strengths of both approaches, using keywords to narrow down relevant results before applying vector embeddings for further refinement. 3. Novel search methods. Implementing innovative search strategies that focus on pinpointing relevant sentences and sections from large datasets could lead to better outcomes. By directly identifying and extracting useful information, these methods can create more reliable responses. 4. Reranking techniques. Using advanced reranking methods can help improve the relevance of search results, although studies show modest improvements. Fine-tuning these models could yield better performance in practical applications. 5. Knowledge graphs. Incorporating knowledge graphs may enhance the system's understanding of relationships between concepts. While traditional knowledge graph approaches have shown mixed results, refining how these graphs are applied could lead to more accurate information retrieval. By combining these strategies, retrieval systems can move away from a heavy reliance on vector embeddings, leading to more accurate and practical solutions for real-world applications.
What significance do the findings related to the limitations of vector embeddings and RAG have for the future development of natural language processing systems?
The findings regarding the limitations of vector embeddings and retrieval-augmented generation, RAG, are significant for the future development of natural language processing, NLP, systems in several ways. 1. Reevaluation of techniques. These findings prompt researchers and developers to reevaluate their reliance on vector embeddings for information retrieval. Understanding that vector embeddings can misinterpret the relevance of items encourages a shift towards more reliable methods that prioritize clarity and accuracy. 2. Development of better models. The challenges identified can lead to the development of more sophisticated models that integrate various approaches, such as synonym-based searches or hybrid methods that combine keyword and embedding searches. This could result in systems capable of providing more accurate and relevant responses. 3. Focus on contextual understanding. The limitations expose the need for NLP systems to better understand the context and meaning behind queries, rather than merely relying on similarity measures. This could drive innovation in semantic search techniques that can discern the nuances of language. 4. Innovative search strategies. Insights from these limitations may inspire the creation of novel search methods that can extract relevant information from large datasets more effectively, ultimately leading to improved chatbot and information retrieval systems. 5. Real-world applicability. Recognizing the impracticality of current RAG methods paves the way for the development of systems that can perform reliably in real-world scenarios. This could enhance user experience by providing timely and accurate responses, which is critical in applications like chatbots. In conclusion, the findings highlight the need for a shift in how NLP systems approach information retrieval, encouraging innovation that moves beyond the limitations of existing methods to create more effective and reliable tools for understanding and processing natural language.
How might the issues associated with vector embeddings and RAG impact the broader landscape of applications that utilize natural language processing, such as customer service chatbots or search engines?
The issues associated with vector embeddings and retrieval-augmented generation, RAG, can significantly impact the broader landscape of applications utilizing natural language processing, such as customer service chatbots and search engine. 1. Decreased reliability. If vector embeddings fail to accurately assess the relevance of information, applications like customer service chatbots may provide incorrect or irrelevant answers, leading to user frustration and a lack of trust in the system. 1. This can hinder the effectiveness of chatbots in resolving customer queries or providing support. 2. Slower response times. The high latency associated with advanced RAG techniques makes them impractical for real-time application. In customer service, where quick responses are crucial, delays can lead to poor user experiences, diminishing the overall effectiveness of the service. 3. Inefficiency in handling large datasets. Although RAG systems are designed for large datasets, their current implementations struggle with accuracy and efficiency. This limitation can affect search engines, which need to efficiently sift through vast amounts of data to provide relevant results quickly. Inaccurate results may decrease user satisfaction and engagement. 4. Stagnation of innovation. The reliance on flawed vector embeddings might discourage the exploration of better methods and technologies in NLP by .dot. If developers continue to follow established practices without addressing the underlying issues, the potential for innovation in more effective information retrieval and understanding will be stifled. 5. Need for better understanding of language. The limitations highlight the necessity for NLP systems to evolve beyond simplistic measures of similarity. Applications must be designed to understand context and semantics more deeply, which is essential for providing accurate and relevant information. In summary, these issues can hinder the functionality and effectiveness of NLP applications, leading to decreased user satisfaction and limiting the potential for advancements in the field. Addressing these challenges is crucial for the future success of technologies like chatbots and search engines in delivering accurate and timely information.
What recommendations would you suggest for researchers and practitioners in the field of natural language processing to address the challenges posed by vector embeddings and enhance the effectiveness of information retrieval systems?
To address the challenges posed by vector embeddings and enhance the effectiveness of information retrieval systems, researchers and practitioners in the field of natural language processing can consider the following recommendations. 1. Diversify retrieval techniques. Instead of relying solely on vector embeddings, incorporate multiple retrieval methods, such as keyword-based searches and synonym-based approaches. This diversification can help improve the relevance and accuracy of search results. 2. Focus on contextual understanding. Develop systems that prioritize understanding the context and meaning behind queries. Techniques that analyze the semantic relationships between words can lead to more accurate interpretations and improve the retrieval of relevant information. 3. Optimize for efficiency. Work on reducing latency in retrieval processes by streamlining architectures and algorithms. Faster response times are essential for applications like chatbots, where user experience is critical. 4. Experiment with hybrid models. Combine different models and approaches, such as fine-tuning reranking techniques and integrating knowledge graphs, to enhance the system's capability to understand and retrieve relevant information. 5. Implement continuous learning. Design systems that allow for ongoing learning and adaptation based on user interactions. This feedback loop can help the models become more accurate over time by refining their understanding of language and user intent. 6. Leverage novel search methods. Explore innovative search techniques that go beyond traditional methods, such as those that can pinpoint specific sentences or sections within large datasets, thereby improving the accuracy of responses generated by NLP systems. 7. Educate on limitations. Ensure that practitioners are aware of the pitfalls associated with vector, embeddings, and RAG systems. Continued education on the strengths and weaknesses of various approaches can lead to more informed decision-making in the development of NLP applications. By adopting these recommendations, researchers and practitioners can work towards overcoming the limitations of current methods and improve the effectiveness of information retrieval systems in natural language processing.
Thank you for joining us today. We've uncovered the strengths and weaknesses of vector embeddings in natural language processing, particularly in information retrieval. While they excel at representing word meanings and relationships, inaccuracies arise, especially in percentage of sameness determination. We've explored advanced RAG techniques and larger language models, but their success is limited. Alternatives like synonym-based search, hybrid search techniques, and novel search methods hold promise. Knowledge graphs and reranking techniques also show potential. These limitations highlight the need for better contextual understanding, innovative search strategies, and a move away from relying solely on vector embeddings. By addressing these challenges, we can advance natural language processing systems and enhance their accuracy and reliability. Thank you again for being here.